Hi, good morning to all. I am Srikanth Reddy, pre lecturer in Electronics Communication Department, working at Government Polytechnic, Chowkpet. Today we discuss the chapter Microwave Communication and Television. The subject code is EC405. In this chapter, today we discuss two topics, that is, list different types of transmission lines, draw the electrical equivalent circuit of a transmission line. List different types of transmission lines and draw the electrical equivalent circuit of a transmission line. First topic, list different types of transmission line. In this, what is transmission line? Transmission line means transferring the information or energy from one place to another place. Here the information is electrical signal in nature or electromagnetic signal. The information is voice, audio, video, text data, anything which is used to transferring from one place to another place by transmission lines. There are various transmission lines are used for transferring the signal from one place to another place. There are different types of transmission line given below. These are basically 5 types of transmission lines. They are: 1. Parallel transmission line. 2. Twisted pair transmission line. 3. Coaxial cable. 4. Waveguides. And 5th, fiber optic cable. Fiber parallel transmission line, twisted pair transmission line, coaxial transmission line, waveguides, and fiber optic cables. In this first topic, parallel transmission lines. The name implies that parallel means it consists of two wires that are in parallel. Here means the wires are conducting materials, conducting elements which are used in to transfer the information from one place to another place. Here the two conducting wires are conductors wires are in parallel. That's why these transmission lines are called parallel transmission lines. We show the diagrams. Here see that two conductors and separated by a insulating spaces. These insulating spaces are protecting from short circuits. Here the two conductors are separated by insulating spaces. These parallel transmission lines are two types. One is open type parallel transmission line. Another one is twin lead parallel transmission line. In open type parallel transmission line, the conductors are in open. The two parallel conductors are open in free space and separated by insulating spacer. In twin lead parallel transmission, the two conductors are covered by insulating material or plastic. These parallel transmission lines are mainly used for power lines, telephone lines, and used to connect a television receiving antenna to a home television set. Second one is twisted pair transmission line. Here, as the name implies, that the line consists of two insulated wires twisted together to form a flexible line without the use of spacer. That means two conducting wires or insulating conducting wires are twisted together without any spacer. These are low cost. These are mostly commonly used in medium today due to its uses in the telephone system. These cables can carry both voice as well as data. The twisted pair cables are used for voice communication in telephone systems and also data transmission up to 100 megabytes per second in nowadays. So mainly used in telephone communication for voice and data transmission. Here the diagram shows that twisted pair transmission lines. Here the transmission lines, the two wires are twisted together, and these twisted transmission pair cables or transmission lines are again divided into two types: unshielded twisted pair UTP and shielded twisted pair STP. Here unshielded twisted pair means the two twisted pair wires are not protected, are not covered by the plastic cover or metal sheet. In shielded twisted pair, the two twisted cables are covered with metal sheet. We easily know the diagrams. This diagram shows the two differences. First one, unshielded twisted pair, there is no metal shield. Shielded twisted pair, there is a metal shield. So metal shields can cover by the two twisted pair covers. So it is called STP. Unshielded twisted pair, there is no metal shield. Third one, coaxial cables. Coaxial cable or coax as an inner conductor surrounded by a insulating layer and surrounded by a outer conductor shield, and the outer conductor is also enclosed in a insulating sheath, and whole cable is protected by a plastic cover, that's called jacket. That means here coaxial cables means co-axis and two axes, that means two conductors and separated by the insulators. Here the diagram shows that one. First one, conductor and covered by the insulated dielectric toll covered, and again this insulator covered by the shield conductor, and the shield conductor again covered by the plastic cover insulator, that's called jacket. So here these two conductors, conductor 1 and shield, and covered by the two insulators, dielectric toll covered and jacket. So there is a coaxial cables. Here the design of coaxial cable gives it high bandwidth capability. Coaxial cable is used as transmission line for radio frequency signals. Its applications including feed line connecting radio transmitters and receivers with their antennas, computer network connections like internet, and distributing cable television signals. These cables are used in television cables and internet cables. Okay, this is called coaxial cable. Next one is waveguides. Waveguides are a hollow metallic tube for transferring electromagnetic energy. Here, the electromagnetic energy signals are transferred in waveguides. These waveguides are normally used for transmission line for frequency above 1 GHz. 1 GHz above frequency signals are transmitted to the waveguides. For frequency below 1 GHz waveguides, dismissions because large, that's why becomes large. That's why these are not transmitted below 1 GHz signals. These waveguides acts as high pass filters. They are used depending on the shape of the waveguides, the waveguides are again divided into elliptical waveguide, circular waveguide, and rectangular waveguide. That means the waveguide shape is in elliptical nature. The waveguide shape is in elliptical nature, then the waveguides are called elliptical waveguides. The waveguide shape is in circular shape, then the waveguides are circular waveguides. The waveguide's shape is in rectangular shape, then the waveguides are rectangular waveguides. These are more types depending on the shape, but mostly we used these three types: elliptical, circular, rectangular. We show the diagram. Next topic is fiber optic cables. Here fiber optical cables are used to transmit the information in the form of light. This means the light signals are transferred in a fiber optical cables. Fiber optics are pure glass about the diameter of human hair. They are arranged in bundles called optical cables and used to transmit information in the form of light signal over a long distance. That means these cables are made with pure glass. Which the diagram shows. Here the fiber optical cable consists of core, cladding and jacket. Here core and cladding are made with glass or silica. These two are made with glass, but there are differences. Their refractive indexes. Core has refractive indexes N1, cladding has refractive index N2, and always the core refractive index is greater than cladding. N1 is greater than N2. Then the light rays are totally transferred in core. Core means here the light rays are transferred. And jacket is used to protecting the core and cladding. So jacket is a protecting cover, plastic or insulating cover. It is used to protect the optical fiber cables. So in optical fiber cables, here the signals are in light signals. So light signals are transferred from one place to another place. These optical fiber cables are more advantageous in present transmission lines. Other transmission lines, they are high bandwidth, carrying information capacity is high, high speed, more security, small in size, less in weight. So these are more advantages than other transmission lines. Less weight, small in size, more security, more high capacity of signals are transmitted, high bandwidth and high speed. These are the advantages of optical fiber cables. So these five are the 5 different types of transmission lines. That is parallel transmission line, one twisted pair transmission line, two coaxial cable transmission line, three waveguides, four and fiber optical cable, 5. These 5 are the different types of transmission lines used in present days. Second topic is draw the electrical equivalent circuit of a transmission line. Draw the electrical equivalent circuit of a transmission line. Here transmission line mainly consists of two conducting wires. So these two conducting wires, each conductor has certain length and diameter. So it will have the resistance and inductance. Here resistance indicated by R, inductance indicated by L, and these two wires are close to each other and there will be a capacitance C between them, and the wires are separated by a medium called dielectric, which cannot be a perfect in its insulation. The current leakage through it can be represented by a shunt conductance G. That means here two conductors are used to transmit the information. These two conductors are some kilometers to some meters length. So each having some certain length and diameters. So which consist of resistor and inductance. And these two conductors are separated by a air ice insulator, otherwise these are separated by a dielectric material. So that means these two conductors are separated by an insulator, that means which consists of capacitor, and here the insulator is not a perfect insulation. So the insulator have some leakage current. So it consists of shunt conductance. So here resistance and inductance are in series and conductance and capacitance is in parallel. Here the diagram shows L are in series, C and J are in parallel. So the transmission lines are from long length, some meters to so many kilometers we can use. So these are consist of resistance, inductance, capacitance, conductance in for long distance, any 2 points. So it is the equivalent circuit of a transmission line. Here L and R in series, C and G are the parallel. Here R means resistance, L means inductance, C means capacitance, and G is conductance. Okay. At radio frequencies, the equivalent circuit diagrams changes. That means here in series the inductance reactance is much greater than the resistance. That means L XL is inductance resistance is much greater than the resistance. That means XL is greater than R. Hence R can be neglected. So XL is exist in series. And similarly, the shunt capacitive susceptance is also much greater than the conductance. That means Xc is greater than G, and hence G can be neglected. So at radio frequencies, resistance and shunt conductance can be neglected, and the resultant transmission is called as lossless transmission. Here shows the diagram of L and C, inductor and capacitance. Here in series, the resistance are neglected, so we can remove it. In parallel, shunt capacitance, shunt conductance G is neglected, so it is removed. So we shows it L and C. So it is the lossless transmission line, or at radio frequencies these two are exist with the resistance and conductance are very less compared to inductance and capacitance. So it is the equivalent circuit diagram of a transmission line and at radio frequencies. Okay. So once again we discuss briefly today topics. First up is list different types of transmission line, and second one is draw the electrical equivalent circuit of a transmission line. Here list different types of transmission line. Here transmission line means to transferring the energy from one place to another place. That means we can transfer the energy, which is called as information, we can transfer from one place to another place. So these transmission lines are basically divided into 5 types: parallel transmission line, digital pair transmission line, coaxial cable, waveguides, and fiber optical cables. Note down these 5. These 5 types. Parallel transmission line, digital pair transmission line, coaxial cable, waveguides, and fiber optic cable. Okay. First one, parallel transmission line. Here parallel transmission line means it consists of 2 wires that are in parallel. That's why this transmission lines are called parallel transmission line. Okay. These are mainly used in power lines and telephone lines, used to connect television receiving antenna in home television set. Okay. Note down the diagram. Here means 2 conductors are separated by a insulating spacer in parallel transmission lines. So these 2 conductors separated by a plastic or plastic insulator. Again by 2 types: open type parallel transmission, thin layer parallel transmission. Okay, draw the 2 diagrams. In open type parallel, these two wires are in free space and separated by insulator. In twin layer parallel, these two conducting wires are covered by a plastic insulator. You know, draw the diagrams, two diagrams. Complete. Second one, twisted pair transmission line. That means the two insulating wires twisted together to form a flexible line without use any spacer. Okay, means two insulating wires are twisted together and there is no spacer between them. Here the diagram shows. These are mainly used for voice communication and telephone systems, voice and data transmissions up to 100 megabytes per second. These twisted transmission lines are again given two types: unshielded twisted pair, shielded twisted pair. Here shielded means the two twisted covered by metal shield. Unshielded, there is no metal shield. Draw it. Two diagrams. Completed. Next one, coaxial cable. Coaxial means we have co-axis, two axes. That is, inner conductor are here the two conductors are there. The inner conductor are covered by one insulator and outer conductor is and covered by the another insulators. So two conductors and separated by two insulators. Here the diagram show first conductor is the and covered by the dielectric cover and second shield, it is also conductor and covered by the jacket plastic cover. So two conductors and separated by two insulators. Okay, right. These coaxial cables are mainly used in television signals, computer network connections or internet connections, okay, radio transmission cables received to the antennas. Okay, these are very high bandwidth capability and used for radio frequency signals. Okay, draw the diagram. These are mainly used in television signals. In present days home television, we can use the television cables. There are two conductors and two insulators are there. Completed, Amma. Fourth one, waveguides. Here, waveguide means it is a hollow metallic tube for transferring the electromagnetic signals. Here the electromagnetic signal means that the frequency range is above 1 GHz signal. In these waveguides, we transmit above 1 GHz frequency can be transmitted. Below 1 GHz signal it cannot be transmission. Okay, right. These waveguides are very high frequency signals transmitted, and these waveguides are different types depending on the shape. Here basically 3 types are there depending on the shape. They are elliptical waveguide, circular waveguide and rectangular. These are easy to construct, that wise these are mainly used. These, if elliptical waveguide means the waveguide within the shape of elliptical waveguide shape. Circular waveguide means the waveguide shape is circular shape, and rectangular waveguide means the waveguide shape in rectangular waveguide. Okay, these 3 types are mainly used in waveguides. Okay, draw the diagrams. The 3 diagrams: elliptical waveguide, circular waveguide and rectangular waveguides. Our subject is microwave communication and television. So here microwave signals are transmitted mainly in waveguides. So next chapters we discuss about briefly of waveguides and waveguides types. What is microwave frequency? Here means the microwave frequency means above 1 GHz frequency range. It is a short wave range signals. Completed. Last one, fifth one is fiber optical cables. Here means fiber optical cable means these transmission lines are used to transfer the information in the form of light optic. So fiber optical cables are used to transfer the information in the form of light. These fiber optical cables are made with glass or silica, pure glass, okay na, about the diameter of human hair, and it is very less size, small in size. Here optical fiber cables are consist of basically 2 parts, core and cladding. This core and cladding is also made with glass, but this core has refractive index is greater than the cladding. That means N1 is greater than N2. Always N1 is greater than N2. Then the light signals are transmitted in a core, and these 2 core and cladding covered by the protecting cover that is called as jacket okay, that is mainly used in plastic or rubber. Okay, these are, and the fiber optical cables has more advantages than other transmission lines, that is high bandwidth and high carrying information, high speed, more security, small in size, less weight. Okay, na? High bandwidth, high capacity, high speed, high security, small in size, and less weight compared to other transmission lines. Okay, na? Draw the diagram of optical fiber cable. Completed. Second topic, today discuss the second topic is draw the electrical equivalent circuit of a transmission line. Here, transmission lines conducting consist of two conducting wires. Okay, na? These two conducting wires are infinity of length and different types of length, some meters to some kilometers. So, these two conducting wires are having some certain length and diameter. So, it consists of resistance and inductance, and these two conducting lines are separated some distance. So, it exists, and these two conductors are separated by distance, and distance are covered by air ice or other dielectric materials. So, these two conductings are separated by a dielectric medium called as air, if we think so, it is acts as capacitance, and the insulator or the dielectric medium as not a perfect insulator. So, it consumes or it leaches some current. So, it also consists of shunt conductors. So, here basically we have four parameters: inductors, resistance, capacitance, and conductance. So, resistance and inductors are in series and capacitance and conductance are in parallel. So, this diagram is called as electrical equivalent circuit of a transmission line. Here, these are some meters to some kilometers range. So, we have taken as LR in series, CG. Capacitance conductance are in parallel with infinity distance, some distance. So, input as taken, output as taken, any 2 points or more points. Okay. Some, if we take as unit length, resistance and inductance are series and capacitance and conductance are parallel. Okay, we have taken 4 parts. Okay. I will draw the circuit diagrams. Okay, completed. In this electrical equivalent circuit diagram, at radio frequencies, that means, okay, at radio frequency, the inductance or inductive reactance is much greater than the resistance. XL is greater than R. So we neglected R, and shunt capacitance, shunt capacitive suspectance is also much greater than shunt conductance. That means Xc is greater than G. So we can neglect it G. So in this step, R and G are neglected, then only okay this transmission line consists of L and C. Okay, so this transmission line is called as lossless transmission line at radio frequencies. Okay, so L and C are there. Okay, draw it. Okay, complete. Right. Two topics are covered. Two topics are covered. Okay. Thank you. Thank you all.